In this video, we are going to be going over performance counters. Our current scenario is that we have a Server 2008 computer configured as an SQL server. So what we're going to do is we're going to explain which subsystems should be monitored and why they need to be monitored. We're going to also explain which counters I've chosen for each subsystem. And then in that, we're going to explain what each data counter captures and why the data is important to monitor. Then we're going to demonstrate creating a data collector set for the selected counters that we have discussed and schedule this set to run. And after we have captured some data, we're going to pull up some various charts and explain to you what all of it means. So first, we're going to go over to Server Manager and drill down the Diagnostics menu and click on the Reliability and Performance snap-in. As you can see, here's a general overview of the resources that are being used. We're going to right click on User Defined and click New and click Data Collector Set. We give it a basic name, Lab8 will suffice. Instead of using a template, we're going to use we're going to create a data collector set manually. For this, we want performance counters, so we're going to check that box and click Next. And here's where we add our performance counters. So we click Add. So the first subset that we're going to monitor is the physical disk. We're going to use the disk read bytes per second counter. This will be able to show us how much data is being read from the disk. For example, for an SQL server, how much data is being read from the database itself. If this counter were giving you a very high read bytes per second reading, that means you probably should think about getting another server to lighten the load. So the next counter that we're going to be monitoring is a data write bytes per second. This will tell us how much the server is writing to the disks. For example, if someone is adding something to the database, at that particular time, this counter would have peaked. So the next subset we're going to monitor is the processor subset. First, we're going to use the idle time and processor time counters. The idle time will give us an indication of how long the server is being inactive, meaning no one is using it. And the processor time is giving us an indication as to how big of the workload is on it. For example, if you have a high idle time, that means that the server really isn't being used. And on the flip side, if you have a high processor time, that means the server is really being used. And if the processor time gets too high, you should think about getting another server to lighten the load. The last and final subset that we're going to monitor is the memory subset. The first counter we're going to use is the committed bytes in use. This will give us a good indication as how much RAM is being used at any given moment. For an SQL server, normally database items that are used more often will be stored into RAM so that they can be accessed quicker. Using this efficiently should also mean that in your physical disk subset, the read and write time should be a little bit different. This is because the data that is being accessed more often is stored in the memory, and the read time for memory is significantly quicker than the read time for the hard disks. So the second counter we're going to use is the available bytes counter. This will give us an indication as to how much RAM we have available to be used. For example, if this counter is high, that means that we're not really using the memory to our advantage, that we should tweak some settings so that database items that are used more often are being stored into memory to increase overall performance. If this counter is low, that means we should either get some more RAM to put in the server. This also could mean that there are a lot of frequently used database items in the RAM currently, and that it is helping it to be used more efficiently. Now that we've added all the counters that we'd like to monitor, we're going to click OK. There's a brief overview of the counters that we've added. We're going to click Next. This is the root directory of where our data for the data collector set will be saved. We're going to accept the default values and click next. Again, we're going to accept the default values here again and click next, or finish rather. Now we're going to schedule this data collector set to run. So we right click on it and click properties, go to the schedule tab. And normally you want to schedule during the peak usage. So we can go ahead and leave April 1st as the date. So we can go and try Monday, Wednesday, Friday, and Saturday. Second out, let's just go Tuesday, Thursday, Saturday. And peak usage, probably around noon is a good time. So we'll go ahead and make this say 12 p.m. We're going to go OK. And click apply. Now we're going to go to the stop condition tab and make the collection set collect data for 2 hours. Now we're not going to make this video last 2 hours, so we're going to go ahead and manually activate the collector set by clicking this start the data collector set button, the green arrow there. As you can see, we have a green arrow saying that it is active, so we'll see in about 2 hours. And we're back, but before we start, I'd just like to mention that while I cut the video, I copied about a 120 megabyte file on the hard drive just to give us some data to work with. So once we open up the log, that'll be what that is. So to go to the log, we're going to go to the default directory where it's saved, which is our local disk, perf logs, admin, 001, and click set home. We're going to double click. It's going to open it up for us. So right now we're just going to zoom in to where we see this peak here. We're going to analyze this. As you can see, like I said, where I copied the data, the blue line is the data write bytes per second, and that's when we wrote the data to the disk. As you can see, the percent committed bytes for RAM is right about 10%. As you can see, the available bytes of RAM is always at top because we're not using any RAM intensive applications. And the disk write, like I said earlier. The idle time, it's been pretty idle because nothing happened. As you can see, the idle time goes down because we were using it to copy the data, which took a little bit of processing time. And then processor time, pretty much idle as well. Here's our histogram. It gives us a different view of pretty much the same data. And we take a look at our reports. This is something you can give to like an administrator to help determine if we need to buy a new server. And then another view, our area view. Last but not least, our shaded area view, pretty much the same thing. This concludes my lab video for Lab 8 in INTC 2030. See you next time.